So at the end of the last lecture, we were talking about arrays in Bash. So I'm just going to quickly go over the basics of arrays, and then we'll continue with the lecture. All right, so remember that when you make a variable in Bash, when you first use a variable in Bash, that's when Bash creates the variable. So here I've got no array variable yet, but I can make one by writing arr square bracket 0 and then assigning it a value. Right? So that actually makes an array variable called arr, sets the element at index 0 to the string hello. Right? Now when you access the value of that, when you want to access the value of an array index, element, right? You just use the regular array indexing notation, right? The same that you'd use in Java or Python. But you have to remember to put everything inside of braces, right? So the name and the index and the square brackets goes inside braces before you dereference it, right? And if you do that, everything works the way you expect it to. Now, Bash, being the way it is, right, doesn't warn you if you incorrectly access the array variable like so, right? So if you try that and run it, you end up with hello square bracket 0, which looks really odd, right? And so what happens here is that Bash treats a dereference of an array as returning the first element of that array, right? The element at index 0, I think. So it expands to the element at index 0, right? So what's at index 0? Well, the string hello is at index 0, right? And then what's up with the square brackets? Well, to Bash, the square brackets just looks like a string. So this is the string hello, right? Followed by the string square bracket 0 square bracket. No error, but obviously the answer is wrong, right? So when you want to dereference an array element, don't forget to put everything inside of braces, right? And that's the other reason why you might consider putting all of your array dereferences inside of all of your variable dereferences inside of braces, right? It saves you from a lot of these little problems like this. Okay, Bash arrays do not, there's no requirement that you start filling in the elements of the array at index 0. Right. So here I'm going to unset the array. So that's going to remove the variable arr from our workspace, right? Or from our shell, I guess. Right. Now I'm going to write arr5 equals weird. Right. So that simply creates an array variable called arr, sets the element at index 5 to the string weird. Oops, sorry. That prints the value of arr5. Sorry there. Right. If you then go back and set the element at index 0 to strange, that's fine. Right? Oh, wait. That was 0. I'm being, oh, sorry. I wouldn't pay attention to the what was written here. There's actually two examples happening in this example here. Okay. So the first point is here. Right? If you just access the variable arr without specifying an index, that gives you the element at index 0. So if you run that, right, you print out element and then nothing. Right? There's nothing here because there is no element at index 0 of the array. Right? So you have to use a, in this case you need the, if you want to print out element 5, you have to ask for element 5, which is down here. Right? Now, if you go ahead and set the element at index 0 to strange, right? Again, when you just dereference the array using the name of the array, that gives you back the element at index 0. So that one actually works, but don't do that. Right? If you want index 0, use the braces, variable name, square brackets, 0. Right? And if you want the element index 5, again, use the braces, followed by the array name, followed by the index. Right. Okay. The expression arri. Oh, yeah. Here's another weird example. Right? So again, I'm going to unset the array. I'm going to assign the element at index 0 to the string strange. And now I'm going to use this. There's no variable called I in our shell yet, right? So if I use the variable I, if you try to use the variable I here, right, you don't get the variable I, right? In other words, it doesn't make up index 0 for you, right? So what ends up happening here, this one's very strange, right? Bash sees the $ARR, right? So that gets substituted for the element at index 0 of the array, which is strange. And then it sees square bracket, I square bracket, which just looks like a string to bash. So you get the square bracket, I square bracket. Yep.
What if you could put
braces?
Yeah.
Boop, boom. Whoop. Strange. Why does that work? Because I is undefined, right? I is undefined, so it gets the value 0. So it gets the empty string. The empty string, when you treat it as a number, is the value 0. So you get the element index 0. Screwy, but that's the way it works, right? So this is all very strange to all of you because you probably only programmed in a modern programming language, right? Like Java or Python, right? Which actually does some, like both languages actually do some amount of syntax checking, right? Bash doesn't really do any of that for you. So you have to be very careful, right? Bash assumes that what you write is what you mean, which makes it very hard to debug. Okay, you can use declare to declare an array if you want to. So declare minus a says that x is an empty array, right? But again, in Bash, it doesn't really matter if you use declare because there are no types. So you can say that x is an array, but you don't have to treat it as though it were an array, right? Here's another example where you can declare an array and then give it a bunch of values. So the round brackets followed by a space-separated list of strings will initialize the array to those strings, right? So this will initialize the array y to the string 10, so that's element 0. Element 1 will be 20. Element 2 will be 30, right? And so if you run that, you'll just get 10, 20, 30, right? The round brackets turn out to be really useful for creating array-type variables, right? So you can do all sorts of, you can play all sorts of tricks with this to turn things, like sequences, into arrays. Right, so the first example makes an array of length 1, right? Its first element is hello. The next example makes an array of length 5, right? Its elements are 0, 1, 2, 3, and 4. If you want to, you can specify the array indexes, right? So this makes an array that has one element at index 1, and it's the string goodbye, right? There's no requirement that the elements be in order. So you can create an array whose element at index 100 is weird, the element at index 0 is weirder, and the element at index 1 is weirdest, right? And this all works just fine if you were to print those out. Okay, so the new stuff for today. How many elements are in the array? Right? Now this one's really awkward to get the elements, the size of an array. The syntax is very funny, okay? So if you want the number of elements in an array, right, then it's $, right? Then the brace, then the hashtag or the pound or the number symbol, whatever you want to call that, right? Followed by the array name, followed by square brackets, and then at inside the square brackets. So I'm going to tell you what at means in a little bit, right? For now, that's how you get the size of an array, right? Syntax is very strange, right? Okay, so here's the same example as before, and this time I'm going to print out the number of elements in each array. Right, so I think there should be 1 here. I think there should be 5 here. I think there should be 1 here, and I think there should be 3 here. Right, so 1, 5, 1, 3 is what I expect to get. Right, and that's what I get. All right, so syntax is weird. That's just the way it is. Right. Okay, so what does this at mean? So when you write the name of an array with the index at, right, then what that, and there's a $ in front, right? Then what that does is it expands all of the elements of the array into a giant string, right? So $, squiggly bracket, array, square bracket, at, or star, right? Both of these do the same thing. So they result in an expansion to all elements of the array. So both result in the string, right? First element of the array, right? Followed by a space, followed by the second element of the array, followed by a space, followed by the third element. This is actually not quite correct. This is assuming that your array, you're using your array like a sane person, right? Your first element's at index 0, your second element's at index 1, your third element's at index 2, right? This is really the first element of the array, the second element of the array, the third element of the array, okay? So they both result in that big string, right? And notice that there's spaces between the strings. So if you feed that into a loop, so you can do something like for each element in that big string, right? And it'll process each element of that string, right? So sometimes that's what you want, right? So all the string itself and all of its elements are unquoted, right? So that's important in Bash, right? It's unquoted. So what does that mean? We know that if you have an unquoted string, right, word splitting happens and file name expansion happens, right? So that's fine, right? You can do this if that's really what you want, right? If your array elements don't contain any spaces or if they don't contain any funny symbols, it might be okay to do this, right? So if it's just plain old text, right, no funny symbols or spaces, then each element of the array will just be interpreted as a string, which might be what you want, right? Normally, though, that's not what you want, okay? So normally, what you want is you want to quote that whole thing and use the at inside, right? Not the star. Okay? So you want to quote everything, and you want the at. Right? Now, what does that do? That produces the same thing as before, except each string is quoted. Right? So now word splitting doesn't happen with each one of those strings, right? And file name expansion doesn't happen with each one of those strings. Right? There's still a space between elements of the array. Right? So you can now process each element of the array, preserving spaces and unusual characters inside each element. Right? That's almost always what you want to do. Right? Almost always. Right? So that's even in the notebooks, right? Boop, boop, boop. So this is almost always the expansion that you want to use. Right? If you use the expansion $array asterisk and quote that, right, then that produces the expansion that's the same as before, right? So each array element separated by a space, right? And then it quotes the entire string, right? So there's a double quote here and there's a double quote at the end, right? So now you get back all of the array elements as a single giant string that's been quoted, right? That's normally not what you want, right? Unless, yeah, it's normally not what you want, right? Normally you want to process each element of the array. That expansion only lets you process everything in the array as though it were a single thing, right? So that's almost never what you want, right? So remember, if you're ever asked to process all of the elements in an array, perhaps using a loop, you probably want that expansion right there, right? Okay, so keep that in mind. So now there's an example of each one of these in a loop. So I haven't shown you a loop yet, but this is how you can loop over the elements of an array. Right? So here I've got the array, a dog, right? A cat, and a fish. Right? So there's 3 separate strings. Each string has a space in it. Right? The first loop is, you read this like a regular Python loop, right? So for each element I in the array, in this expansion here, right? In that expansion there. Right? Now remember what that expands to. That expands to the string, a dog, a space dog space a cat, sorry, a space dog space a space cat space a space fish, right? It actually expands into 6 separate strings, right? So when you run this, it's going to print 6 things, right? A dog, a cat, a fish, right? If I use at, right, but I don't quote the expansion, right, that's going to do the same thing. Right? So star and at do the same thing if you don't quote the expansion. Right? So because they do the same thing, you're going to get the exact same output. Right? Now, if you quote the expansion, right, and use at, right, now you're going to get each separate string as though it were quoted. Right? So I'm going to get the string a dog quoted, a cat quoted, and a fish quoted. Right? So now I'm going to get now I'm going to process 3 strings, which is what I probably want to do. Finally, in the last example, right, if I use the star in the expansion, right, but I quote the entire, if I quote the entire expansion, right, then you just get one giant string, right? And so when you print this, you get one giant string, which probably not what you want. I guess there are some unusual use cases where that might be what you want. Right? But almost always what you want to do is the third one right here. Right? Okay, any questions so far? All right. Now, because you don't have to index your elements sequentially in bash, there has to be some mechanism that lets you get back the indexes that are used in an array. Right? So the syntax to get back the list of indexes used by an array, $, squiggly bracket, exclamation mark, ARR, followed by an @ inside the brackets. Right? I believe star works here as well in both of these examples. In the other example as well, the number of elements. But @ is the standard. Right? So this gives you back the list of elements that are used, the list of indexes that are used. Right? So for that array there, there's only one index used. That's index 0. Right? This array here should be indexes 0, 1, 2, and 3. Right? That array there is just index 1. And this one should be 0, 1, and 100. So you get back a sorted list. Right? So when you print these out, there you go. Right? We've used index 0 in the first array. We've used these 4 indexes in the second array. Right? Just index 1 in the third array, and 0, 1, and 100, in the last array. Right? Now, if you want to write a loop that counts, right? So in other words, you want a counting style loop, right? Then you can use, to process all the elements of an array, then this syntax is useful for that purpose, right? So for each element I in the indexes of the months array, right? So for each element I in the indexes of the month array, so in this case 0, 1, 2, 3, 4, right? I can access element I out of the array. Right? Similarly, I can print that element on the next line. Right? So there you go. Right? So month 0 is January, month 1 is February, and so on and so on and so forth. Right? Now, if you happen to use different indexes, so we can quickly change this. So let's do something silly like 3 equals, no space. 3 equals February, 9 equals March for some reason, 12 equals April, and then how about 100 equals May, right? This still works, right? Obviously the indexes are different, but the loop still works. Right? Funny enough, that works there, even though there's, right, no, there we go, that's better, okay. Right, so that still works. Right, so if you need the indexes, and so number one, if you have some reason to believe that you did not use sequential indexes, then this is how you can process the elements of the array, right? While getting the indexes at the same time, right? If you're actually a sane programmer and you do the sensible thing, you can just use a regular counting style for loop, which I'll show you a little bit later today. Right? All right, any questions so far? Yeah.
If you tried like unassigning May from an index,
Yep.
would May be on index 13?
So you mean leave off the index here?
Yeah, if you just took off the index.
It's going to be something unusual, I bet. So it is 13 in this case. Okay, so it is the next one in sequence. Yeah.
Is that for all cases?
Pretty sure, but I would have to actually look up exactly what the manual says in this particular case. But I'm pretty sure it's the next available index. So I guess we can try that out. So let's do something crazy like 100, right, like that. So if we're right, then May should be 101. And, oh, see, it's not, right? So there you go. So it's not anything sensible at all, right? So it looks like what it's doing is it's adding 1 to the to the previously used one, which begs the question: what happens if you made this 13? Because that's going to screw things up. So what happens now? Oh, there you go. It nukes January. It's just the way it is. I didn't invent this. I didn't invent this shell, right? That's just the way it is. Okay. So the rule of thumb is always don't do this, right? Right. Be sensible. Try to use sequential indexes, right? You could probably write some really confusing programs doing this, but anyway. All right. Any other questions? This is the nice thing about these notebooks, by the way, is if you ever have a question, you just change the notebook and see what happens, right? You run it right away, right? It's way easier than having to edit a script and then saving the script and then running the script. All right. Can you concatenate arrays? The answer is yes. You can concatenate two arrays. Again, the syntax is wacky, right? So if you want to concatenate an array 2 to the end of array 1, then what you can write is array 1 plus equals. Now, you have to now convert array 2, the elements of array 2, into a new array. Right? So you have to convert the elements of array 2 into a new array, even though array 2 is already an array. Right? I know it sounds weird, but that's the way it is. Right? So how do I convert the elements of array 2 into a new array? Right? Well, I know what this does. Right? If I quote the expansion ARR2 at, right, I know that each element of the array I get back as a quoted string. Right? So I now have a list of quoted strings. Right? How do I convert that into an array? Well, I just wrap that up with round brackets. Right? So round bracket here, makes a new array. Right? And now I can concatenate that array onto the end of array 1. Right? Notice that you can't just write ARR1 plus equals ARR2. That doesn't work. Right? Why doesn't that work? Because ARR2 looks like a string to bash. Right? So that's not going to work. $ARR2 expands to the first element of the array, so that doesn't work either. Right? That's why you have to use this wacky notation. All right. So here we go. So A, right, has one element in it. It's an index 100. Right? B's got three elements in it, 5, 6, and 7. Right? I'm going to, what am I doing here? Why did I double quote all of that nonsense? Double quote. Why is that double quoted? Well, let's see what happens. I don't know what's double quoted. Okay, so we get 0, and then 5, 6, 7. Right? The indexes that are used are 100, 101, 102, 103. Right? Now, why is this double quoted here? Hang on.
Turn it back into one string?
You shouldn't need it. I don't think it makes a difference. I don't know why it was double quoted there. Yeah, it doesn't make a difference. I'm not sure why it was double quoted. Sorry. Okay. Right. Okay. So there's the elements of the array A, and there are the indexes that are used in the array A. Right. Now, I'm pretty sure in this example, it always adds to the end of the array. In other words, so in this case, it really does use the highest index. So it appends to the highest index in the array. Okay. All right. Interactively reading elements into an array. So there's a command I haven't told you about called read. It's a built-in command. So read will let you interactively read stuff from standard input. Right? So if you wanted to write a prompt to ask the user to type in some information, read is one way you could do it. Right? If you wanted to read in all the stuff they type in into an array, right, then you use -a as the option to read. Right? So read -a and then the name of an array will read from standard input a bunch of elements into the array ARR. Okay? If you want to, you can include a prompt. Right? So -p followed by a space followed by some string to ask the user for some input. Right? We'll then print the prompt, and then the user can type in their elements. Right? Now, Jupyter doesn't support interactive input, so you can't actually run this example in Jupyter. You have to write your own script to do this. Right? But if you wanted to do something like this, right, that's how you could enter in a list of stuff. Ask the user for a bunch of space-separated elements, and it'll store each element into the array, or each string into the array ARR. So that's how you do it if you ever need to do that sort of thing. Right? All right. Any questions on arrays? I don't think there's anything else you can do. So you can't slice an array like you can in Python. There's no easy way to get a sub-array of an array that I know of in Bash. Anything else you might do with an array? I guess the difference between a Bash array and a Java array is that you can expand the size of a Bash array without having to do anything special. Other than that, they behave, if you use them sensibly, right, they behave the same as arrays in other languages. All right. Any questions? All right. Now that I've shown you a loop, I might as well actually tell you what loops look like. So Bash has 4 types of loops. There's until, while, a for loop that loops over the elements of a list, so that's like Python's for each loop. And then there's a counting style loop that is similar to the C style loop or the Java style counting loop if you've taken CISC220. I guess if you're taking it now, you've seen the counting style loop in Java, so it's similar. Right? You've got break and continue. So break and continue behave the same in Bash. That's not quite true. They almost behave the same. Break and continue almost behave the same in Bash as they do in Python and Java. The difference is in Bash, you can specify which loop to break or continue from. Right? So if you have a nested loop and you break out of the inner loop in Java or Python, that always breaks out of the inner loop. Right? It's possible in Bash to break out of the outer loop from inside the inner loop if you need to, but that's unusual as well. Okay, until and while. So remember how if statements work, right? So if statements work by the condition is a command. Well, one of the ways an if statement works is if the condition is a command, right? And then it looks at the exit status of the command to determine whether or not the body should run. Right? So if the exit status of the command is 0, then the body runs. Right? And if the exit status is not 0, then the body does not run. Right? So similar to the if statement, you can also use the exit status of a command to control a loop. Right? So the structure of the condition is the same for a loop as it is for an if statement. Right? So until. Right? The until loop runs until this condition is, oh, sorry, I keep on forgetting I can't do that. Right? An until loop runs as long as that condition is false. Right? A while loop runs as long as that condition is true. Right? So the other way to think about this is until runs until its condition becomes true. Right? While runs until its condition becomes false. Right? So you can, if you want to, write your loop conditions using commands. Right? It's a bit unusual to do that. Right? Instead, what's more common is that you write some condition involving the double square brackets or the double round brackets if it's an arithmetic expression. Right? So, but it can also be written as until a equals b. Do. Okay, so here this loop will run. Right, until your variable a is equal to the variable b, right? When that's true, right, the loop will stop. Right? Here, this loop runs as long as this. Oh, this is an infinite loop, right? Minus n, right? Is the loop empty? Right? Sorry, is the loop not empty? Sorry, is the string not empty? Minus n abc, right? Minus n string. So is the string not empty? Well, abc, the string abc is not empty. So this loop runs forever. Right? Here's an arithmetic style loop. Right? This loop will run until 1 plus 1 is less than 1. That's going to run forever. Right? And here's a while loop that runs forever. Right? Well, 1 is greater than 0, do something forever. Right? So those are all examples of infinite loops. In this case, assuming you don't change a or b inside the loop body. Oh, wait, sorry. I'm being a dummy. Sorry. A equals b. So is the string equal to b, the string b? The answer is no, right? It's never true, right? The string a is never equal to the string b, so that loop runs forever. I got confused there. I thought it was the variable a and the variable b, right? It's not. It's while the string a is the string a equal to the string b, right? The answer is never, so that loop runs forever. Okay, if you want to count from count down to 0 starting from 10, there's lots of ways to do it. Right? So this is how you do it with an until loop. So the count starts at 10, right? Until the count is less than 0, do something, right? So here I'm just going to print out the count, right? Each time through the loop, make the count go down by 1, right? If you want to, you can write this differently, right? So you can write it like that, or you can write it like count equals count minus 1. Right? Both work in this case. Right? Either one's fine. If you want to use a while loop, which most of you probably would want to use a while loop instead, right? Just count. The loop should run as long as the count is greater than minus 1. Right? Each time through the loop, decrement the count by 1. Right? And if you run this, obviously it does what you expect it to do. Right? So it counts from 10 down to 0. Okay, here's the Collatz conjecture. Most of you have probably seen this because you've probably taken some course with me, right? So the Collatz conjecture says if you start with a positive integer n and repeat the following steps, then the value of n will eventually equal 1. Right? So if n is even, then you just set n equal to n divided by 2. Right? If n is odd, you multiply n by 3 and add 1 and then assign it back to n. Right? There's a famous mathematical conjecture. No one knows if it's true. They've tested it on lots of values, but no one's actually ever been able to prove if this is true. Right? This is easy to write using a for loop, using a while loop. Sorry. Right? So all of this stuff up here, this is just validation. Right? So is the number of arguments input? This expects the value n to be on the command line. Right? So is the number of arguments equal to 0? If so, then you're missing the value n. Right? It exits. Right? Whoa, sorry. All right. If the value is not an integer, it exits. Right? So remember, there's our regular expression for being an integer. Right? If the value is less than 1, it also exits. Right? Because this drives n down to 1. And then finally, all you need is a little while loop. Right? Right? So while the value is not equal to 1, right? So you check for even or oddness, right? So if the value is even, right? Divide the value by 2 and assign it back to value, right? Otherwise, multiply the value by 3, add 1, and assign it back to value, right? And go ahead, right? So if you try it out, so I think this one prints out a surprising amount of stuff, right? So if you run this for the number 27, it actually takes a while before it stops, right? It goes on for quite a long time. But it does eventually get down to 1. Right? If you try this for any value up to, well, the conjecture is if you try this for any value n, it will always reach 1 eventually. If you can prove it's true, you'll probably win some money. But no one's been able to do it, despite a lot of effort. A surprising amount of effort. Right? There are people with PhDs running around trying to prove if this sequence goes down to 1. Okay, for loop over elements in a list. Right? Now there is no list type in Bash, right? But when you read the Bash documentation, you'll often see this term list. Right? So a list is just a sequence of strings that are separated by spaces. Right? So if you want to loop over an element, if you want to loop over a list, then just use the Python style list loop. Right? For each variable in your list, right? Semicolon, do, commands, done. Right? So done ends the for loop. Right? So do and done, that marks the beginning and end of the body of the loop. Right? That semicolon there is important if you write it this way. Right? If you write the do on the next line, you don't need the semicolon. Okay. So now remember, a list is just a space-separated sequence of strings, right? So there's my list. Right? It's just a bunch of strings separated by spaces. Right? So this thing will also count down to 10. Right? So for each element I in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, right? Echo I. So that will also count down to 10, down from 10 to 0. Right? So remember, a list in Bash, just a bunch of strings separated by spaces. right? If your individual strings have spaces in them, you have to quote them. Right. Now that list of strings you can generate anyway, right? So a lot of bash expansions generate lists of strings. Right? So word splitting after parameter substitution produces a list, right? So here's my string, right? It's quoted, right? Everything's quoted, right? So I've got one giant string, right? If I take that giant string and ask for its value, right, via parameter substitution, right? And then what happens is after parameter substitution, word splitting happens, right? So this string, str, actually gets split into this is a string with words separated by spaces. Right? So that one actually does print each word on its own. Right? Now you might say, hey, string is quoted. Right? Well, no, the contents of the string is quoted. You didn't quote the variable. Right? If you want to prevent word splitting from happening, you quote the variable. Right? Oh, sorry. And now you just get the single string. Right? So if you want to process all of the individual words in a string, right, this is one way to do it. Where the string is stored in a variable, then this way works. Right? Notice here, it's intentionally unquoted, right? So that the shell performs word splitting, right? What does file name expansion do? Well, file name expansion produces a list of files, right? A list of file names, where each file name is just a string. Right? So if I do something like the following, right? So so what does this expand to? Well, it expands to all the files that end in .sh, that end in sh in the directory scripts/loops, right? Right. So that expands to all of the shell scripts in this directory. So if you print that, you end up with each shell script that's in the directory scripts/loops. Right. Okay, now the super annoying thing in bash. So when you do a file name expansion like this, right, there is the possibility that that expands to nothing. Right? So if there are no PDF files in this directory, right, then that doesn't match any file in the directory. Right? Now, what bash does if that happens, right, is the expansion doesn't happen. You end up with that string. Right? So in this case, I'm going to end up with the string ./scripts/loops star.pdf, right? Because there are no files that end in PDF in that directory. Right? So when you do that, you end up with that. And this is another potential source of error, right? Because now you're going to try to process this file, but this file doesn't exist, right? And so that doesn't work. So you have to be very careful about that, right? If you're trying to process a bunch of files in a directory, you have to make sure that that directory is readable, readable and executable, right? And then you can read all of the files that are in that directory, right? If they're not, you end up with errors like this. Okay, there's a brace expansion. Now we haven't used many of these in the course, right? So remember, this expansion produces the sequence 10, 9, 8, 7, 6, 5 down to 0, right? So it produces the integer sequence 10, starting at 10, going down to 0, right? And so that works just fine, right? Command substitutions, right? So most bash commands produce some output, right? That's just the way they work. So you can take the output of that command and process that using a loop, right? How do you do it? Well, you use a command substitution, right? What does command substitution look like? So remember, it's $single round bracket, right? Some command inside the round brackets. The output that gets written to standard output from that command gets substituted for the entire expression there, right? So sequence. SEQ is the bash command that can generate a sequence of values. So this says generate the sequence, I think it's starting at 10, step size of -1, going down to 0. So that's start, step, stop. Right? So this is also going to count down from 10 down to 0. Right? Notice that there's like 6 or 7 different ways that you can count down from 10 to 0 in this notebook. Okay. What about grep? Right? So remember grep. Right? So grep is our command that can search files for a regular expression. Right? So here I'm going to use grep to search for the string if inside my file called colats.sh, right? So that's the colats conjecture. Right? Minus n, that prints out the line number of the line that matches. Right? Okay, now this command goes on for a bit. Right? So that's so I'm going to take the output of grep here. Right? Now what's grep going to print? So it's going to print out some line number, right? And then the line that matches that regular expression. So this is going to print out all the lines that have the word if on that line. Right? Now if I just want the line numbers, right? So I just want the line number, then you can use this command called cut. So cut will cut columnar data or columnar strings. Right? So let me back up here, just 1 second here. So I'm going to back up and show you this one step at a time. Oop, oop, oop. Wait, so I'm going to copy that. I'm going to comment out the line. I'm going to paste that in. Okay, so let's just look at the output of grep instead of the entire pipeline. Okay, so let's do that. Okay, so the keyword if appears on. Now, you get some funny output. Right? So I get 5, and then I get if, and then I got these round brackets, and then I've got this, right? So you can see here that word splitting has occurred on that output, right? Which I probably don't want, but I'm kind of stuck with that at the moment. Right? Then on line somewhere, 15, there's another if statement, right, with, again, the rest of the line. Then on line 21, there's another if statement with the rest of the line, and so on and so forth. Right? Now, if I just want the line numbers, then we can pass it to this command called cut. So let's take a look at that. Okay, that's better. Right? So now that thing appears on the lines 5, 11, 15, and 21. Right? I guess the better way to do this would have been to do this. So let me just copy that line there and stick that here so that you can actually see what grep is outputting. Okay, so this is what grep is outputting right here. Sorry. Grep is outputting that stuff here, right? So you can see that grep prints the line number followed by a colon, followed by the contents of the line where the word if appears, right? The cut command will let me separate out if I just want the line number, I can use cut. So I can cut the line, right? I can cut each line, right, at the colon, right? And so it's cut minus d colon. So minus d is short for delimiter, right? So what character do I want to split the line on, right? So I want to cut it at all the colons, right? And I want to keep the first part of the string that was cut. Right? So I want to keep the number, right? And so cut calls those fields. So I want field number 1, right? So minus F1, keep field 1, right? After splitting at all the colons. And so that generates the output. That gives you just the line numbers on which the if statement has occurred. Right? So notice that you can write some quite sophisticated not just loops, commands, by using pipelines. Right? All right, and the last type of loop for today. So there's a C-style loop, right? So this is the for int I equals 0, I is less than something, I plus plus, right? That's this type of loop, right? So if you want to write that type of loop, and it's very common to write that kind of loop, right? Then use the double round brackets, and now your expression 1, expression 2, and expression 3 those are basically the same as what you would write in Java, right? And it works the exact same way, right? It's just that there's no int I in this case, right? So if I want to count down from 10 to 0, I starts at 10, right? The loop runs as long as I is greater than or equal to 0. At the end of each loop iteration, subtract 1 from I, right? And that's like the 8th way to count down from 10 in this notebook. All right, finally, many commands that you write, or many scripts that you write, will accept more than one file name or more than one command line input, right? If you want to process all of the command line inputs, right, then the way you do it is as follows, right? So this script here does something for each argument on the command line, right? So $@ which I mistakenly told you is the number of arguments, it's not. $@ expands to all of the command line arguments, right? If you quote them, right, you get each command line argument separately quoted, right? So for each command line argument, do something with that argument, right, with arg. Right? So for example, in this example here, right, there's one argument here, right? There's a second argument here, right? It's a quoted string. There's a third argument here, which is also a quoted string, right? So there are 3 command line arguments in this example, right? When you run that, it tells you $1 is the first command line argument, right? The second command line argument is the second string, right? And the third command line argument is the third string. Right? So whenever you want to process each element, each string on the command line, right, that's the easiest way to do it with that for loop there. Super. Any questions? All right. I guess I think that's almost it for scripting. Oh, there's functions. So once we do functions, which will take like part of a lecture, we're done with the actual bash scripting stuff. So after we do functions, I'm probably going to go through several examples of writing some bash scripts. And then I guess after the midterm break, we're into the C part of the course. Okay? All right. See you on, when do I see you guys next? Tomorrow? Friday. Tomorrow.